Good afternoon. We are Group 4 and ito po ang aking mga members ay Nakanyonero, Shai Magtalas, Joan Manarang at ako po, Janice Montermos. At ang sinagutan po namin ay Collaboration Set B. And to start, we have Aina.
For the test 1 po, we have true or false. For 1 to 2, the union of two subgroups of a group G is also a subgroup of G. So, ang answer po namin is false. We assume that H sub 1 is a union of H sub 2 is a subgroup of G. So, since H sub 1 is a subgroup of H sub 2, is not a subgroup of H sub 2, there exists an element A where A is an element of H sub 1 but not an element of H sub 2. And then H sub 2 is not a subgroup of H sub 1. There exists an element B where B is an element of H sub 2 but not an element of H sub 1. So by multiplication po, we have A and B. So the product is either an element of H sub 1 union of H sub 2. It follows that either AB is an element of H sub 1 or AB is an element of H sub 2. To solve po, B is equal to AB is an element of H sub 1. Since yung element po ng ating H sub 1 is A, we have B is equal to A inverse multiplied by AB is an element of H sub 1. By associativity, B is equal to A inverse multiplied by A multiplied by B is an element of H sub 1. By the definition of inverse po, A inverse multiplied by A is equal to E. So we have B is equal to E, B, element of H sub 1. By identity, A multiplied by B is equal to B. So we have B is equal to B, an element of H sub 1. To recall po, sa binanggit po natin kanina, ang element po ng ating H sub 1 is A. So B is not an element of H sub 1. To prove naman po, if AB is an element of H sub 2, we have A is equal to AB, an element of H sub 2. A is equal to AB multiplied by B inverse is an element of H sub 2. Since yung B yung element ng ating H sub 2, kaya yun po yung kinuha nating inverse. By associativity po, makukuha po natin is A is equal to A multiplied by B inverse and B, then element of H sub 2. By inverse po, we get A is equal to AE, which is yung identity, an element of H sub 2. By identity, we will get A is equal to A, an element of H sub 2. Recall po that A is not an element of H sub 2. Therefore, we conclude that H sub 1 union of H sub 2 is not a subgroup of G.
Next po, 3 to 4. Let G is an element, is the set of A, be a cyclic group of order n, then A raised to m sa generator of G, if and only if m and n are relatively prime. So, ang sagot po namin ay true. And ito po yung proof namin. Suppose we have G equals to the set of A in order of n. So now, order of G is equals to n. And recall that the order of the subgroups must be a factor of order of G. So let us assume that m and n are relatively prime. Therefore, m is not a factor of G. And by definition of relatively prime, the GCD of m and n is 1. Next po. And then suppose there exist integers p and q such that mp plus nq is equal to 1. Since a raised to I is an element of G and whose exponent I is relatively prime to the order of n, we have now a raised to n equals to e. And we assume that m and n is relatively prime. By replacement, we have a raised to mp plus a raised to nq equals to a raised to 1. So by loss of exponent, we have a raised to mp multiplied by a raised to nq equal to a raised to 1. So we have po, pinag-iwalay po natin yung a raised to m sa p and a raised to n sa q para makuha po natin yung identity. So nakuha po natin identity, meron na lang po tayong a raised to m times p equals to a. And since m and n is relatively prime, therefore a raised to m is a generator of G. So, for number 5 to 6, all even permutations from a group. So, ang answer po namin is true. So, ito po yung proof. The set of even permutation referred by a special name as alternating group degree n or a sub n. So, using the theorem on subgroups, so we need to show that the inverse of A is under A sub n whenever A is under A sub n. So recall, so uh, we know that any two cycle permutation elements y under A sub n will have the inverse of y in A sub n. So to test for closure, let x, y under A sub n where alpha and beta is a product of an even number such as 2x and 2y of two cycle permutation. So by multiplication, 2x plus 2y. So factor out 2, then hence alpha times beta under A sub n. So this proved that the set of even permutations in S forms a subgroup of S sub n.
So for number 7 to 8, the set of H under usual addition is a trivial subgroup of set of Z sub 8 under usual addition where H is equal to 0, 2. So ang answer namin is false. So to prove, let C sub 8 is equal to 0, 1, 2, 3, 4, 5, 6, 7, and H is equal to 0, 2. So clearly, to test whether H under usual addition possess properties of a group, we will test the closure showing through Cayley's table. So this is the Cayley's table. Through the Cayley's table, the set of H under usual addition does not satisfy closure because 2 plus 2 is equal to 4, where 4 is not an element of H. Next po. Therefore, the set of H under usual addition is not a subgroup of C sub 8 under usual addition where H is equal to 0, 2.
For number 9 to 10, our answer is true. And the question is, if H is a subgroup of a group G and if A and B is an element of G, then A is an element of HB. So the first thing to do po is we need to know if A is an element of HA. So suppose that HA is equal to H, and there exists an identity element E for H, we will have E multiplied by A is an element of HA. By the definition of a identity, E multiplied by A is equal to A. Therefore, A is an element of HA. Recall that HA is equal to H. Conversely, suppose that A is an element of H, we want to show that HA is equal to H. So let X is an element of HA where X is equal to HA for some H is an element of H. So H multiplied by A is an element of H. So we will get X is equal to, by multiplication, HA is an element of H where X is equal to HA for some H element of H. So recall that X is equal to HA. By substitution, from HA, an element of H, we will get X is an element of H. Since X is an element of H, therefore HA is a subgroup of H. Now let X is an element of H. Since A is an element of H, where H is a subgroup of G, we have X multiplied by A sub 1, an element of H. So we need to operate both sides by A, and then we will get X multiplied by A inverse multiplied by A is equal to HA. By associativity, X multiplied by A inverse and A is equal to HA. By the definition of inverse, A sub A inverse multiplied by A is equal to E. So we will get XE is equal to HA. By the definition of identity, X multiplied by E is equal to X, we will get X is equal to HA. Since X is an element of HA, therefore H is equal to HA. Hence, HA is equal to H. Now let's prove that HA is equal to HB. We will use the B inverse an element of H. Suppose that HA is equal to HB. Recall that E, which is your identity, is multiplied by A is equal to HA, or simply A is an element of HA. And then recall again that HA is equal to HB. If A is an element of HB, we get A is equal to HB, where AB is an element of G and H is an element of H. By substitution, AB inverse is equal to HB and B inverse. By associativity, pagsasamahin po natin yung B and then yung B inverse. By the definition of inverse, B multiplied by B inverse is equal to E. So we will get HE. By the definition of identity, H is an element of H. Hence, AB inverse is an element of H. So we need to prove that HA is equal to HB. So let AB inverse is an element of H. Since AB inverse is an element of H, so AB inverse is equal to H for some H, which is element of H. So AB inverse multiplied by B is equal to HB. So by associativity po, ang pagsasamahin po natin yung B inverse and then B, we will get A multiplied by B and B inverse B is equal to HB. By the definition of inverse, B inverse multiplied by B is equal to E. So we have A E is equal to HB. By the definition of identity, we will get A is equal to HB. Therefore, HA is equal to H multiplied by HB. HA is equal to HH multiplied by B. Since H is an element of H, so H, big H and small h is equal to H. Hence, HA is equal to HB. By the definition of identity, since A is an element of H, where HA is equal to HB, hence A is also an element of HB.
Next po, we have the second part, which is the completion. So sa number 1, we have given a one-line notation. So gamit po yung one-line notation, nakabuo tayo ng two-line notation, which is 1 maps to 5, 2 maps to 6, 3 maps to 7, 4 maps to 4, 5 maps to 1, 6 maps to 8, 7 maps to 3, 8 maps to 2, and 9 maps to 9. So we have a product of transposition. Meron tayong 1, 5, 3, 7, 6, 2, and 6, 8. Since meron po tayong apat na transposition, ang sagot po natin ay even. And ang order po nito ay 6 dahil meron po tayong cycle of length na 2 and 3 and the LCM of 2 and 3 is 6.
So yung pangalawa po, ito po yung one-line notation, 1, 4, 5, 2, 9, 3, and 6, 7. So the product of transposition is 1, 5, 1, 4, 2, 3, 2, 9, and 6, 7. So meron tayong 5 products of transposition kaya even siya, ay odd siya. So ang order niya is 6.
So for number 3, this is the two-line notation. 1 maps to 7, 2 maps to 3, 3 maps to 5, 4 maps to 1, 5 maps to 8, 6 maps to 4, 7 maps to 6, and 8 maps to 2. So the product of transpositions, we have 4, 6, 4, 7, 4, 1, 8, 5, 8, 3, and 8, 2. Since we have 6 product of transposition, it is even, and the order is 4 since we have 4 in one line notation.
For the next number 4, the one-line notation is 1, 7, 3, and 2, 4, 5, 6. So the product of transpositions are 1, 3, 1, 7, 2, 6, 2, 5, and 2, 4. Since we have 5 product of transpositions, it is odd. Then the order is equal to 12.
So for the last, we have the two-line notation, which is 1 maps to 5, 2 maps to 2, 3 maps to 3, 4 maps to 6, 5 maps to 4, 5 maps to 7, 6 maps to 4, and 7 maps to 1. So the product of transpositions is 5, 1, 5, 7, and 4, 6. So it is odd. Now the order is 6. So here is our solution for the completion.
So the third part is problem sets. So this is the given. For letter A, B times A by replacement. So A times B by analyzing the mappings, we will have the two-line notation. B is equal to 1 maps to 9, 2 maps to 6, 3 maps to 5, 4 maps to 2, 5 maps to 8, 6 maps to 4, 7 maps to 7, 8 maps to 1, 9 maps to 10, and 10 maps to 3. So by analyzing the mappings, we will have the one-line notation. B is equal to A. B times A is equal to 1, 9, 10, 3, 5, 8, and 2, 6, 4. So for letter B, B inverse of C. So by replacement, inverse of C is equal to, and then by looking at the mappings, C inverse of C is equal to 1 maps to 2, 2 maps to 6, 3 maps to 10, 4 maps to 1, 5 maps to 8, 6 maps to 4, 7 maps to 5, 8 maps to 3, 9 maps to 9, and 10 maps to 7. By replacement, so this is the answer. Then, but by analyzing the mappings, we will have B inverse of C is equal to 1 maps to 7, 2 maps to 8, 3 maps to 9, 4 maps to 2, 5 maps to 1, 6 maps to 6, 7 maps to 3, 8 maps to 10, 9 maps to 4, 10 maps to 5, and the one-line notation is 1, 7, 3, 9, 4, 2, 8, 10, 5. For C, inverse of A, inverse of B. So inverse of A by replacement. So by looking at the mappings, the two-line notation is 1 maps to 4, 2 maps to 7, 3 maps to 9, 4 maps to 2, 5 maps to 10, 6 maps to 5, 7 maps to 3, 8 maps to 8, 9 maps to 6, and 10 maps to 1. So inverse of B by replacement. So by looking at the mappings, the two-line notation is equal to 1 maps to 8, 2 maps to 1, 3 maps to 5, 4 maps to 9, 5 maps to 7, 6 maps to 4, 7 maps to 2, 8 maps to 6, 9 maps to 10, and 10 maps to 3. So now for inverse of A times inverse of B, by replacement. So by analyzing the mappings, we will have 1 maps to 8, 2 maps to 4, 3 maps to 10, 4 maps to 6, 5 maps to 3, 6 maps to 2, 7 maps to 7, 8 maps to 5, 9 maps to 1, and 10 maps to 9. So the one-line notation is equal to 1, 8, 5, 3, 10, 9, and 2, 4, 6.
Now, for the inverse of C raised to 4, recall that, so ang uunahin natin is the C raised to 2. So by analyzing the mappings, we will have 1 maps to 6, 2 maps to 4, 3 maps to 5, 4 maps to 2, 5 maps to 10, 6 maps to 1, 7 maps to 3, 8 maps to 7, 9 maps to 9, and 10 maps to 8. So by replacement, our C4 will be 1 maps to 1, 2 maps to 2, 3 maps to 10, 4 maps to 4, 5 maps to 8, 6 maps to 6, 7 maps to 8, 5, 8 maps to 3, 9 maps to 9, and 10 maps to 7. Now, by replacement again, we will solve for the inverse of 4 raised C raised to 4. So we will have 1 maps to 1, 2 maps to 2, 3 maps to 8, 4 maps to 4, 5 maps to 7, 6 maps to 6, 7 maps to 10, 8 maps to 5, 9 maps to 9, and 10 maps to 3. So the one-line notation of C raised to negative 4 is 3, 8, 5, 7, 10 in S sub 10. So letter E, the given is A times B times the inverse of C. So by replacement, A times B, we will have 1 maps to 4, 2 maps to 2, 3 maps to 5, 4 maps to 9, 5 maps to 7, 6 maps to 8, 7 maps to 6, 8 maps to 10, 9 maps to 1, and 10 maps to 3. So we will find so recall that our inverse in C is 1 maps to 2, 2 maps to 6, 3 maps to 10, 1 maps 4 maps to 1, 5 maps to 8, 6 maps to 4, 7 maps to 5, 8 maps to 3, 9 maps to 9, and 10 maps to 7. So by replacement, we will have A times B times the inverse of C is equal to 1 maps to 2, 2 maps to 8, 3 maps to 3, 4 maps to 4, 5 maps to 5 maps to 10, 6 maps to 9, 7 maps to 7, 8 maps to 8, 9 maps to 1, and 10 maps to 6. So our one-line notation will be 1, 2, 8, 5, 10, 6, and 9 in S sub 10. So the last letter, we have the inverse of the quantity of A times C times B raised to 4. So by replacement, B squared is equal to 7 maps, 1 maps to 7, 2 maps to 5, 3 maps to 9, 4 maps to 8, 5 maps to 10, 6 maps to 1, 7 maps to 3, 8 maps to 2, 9 maps to 6, and 10 maps to 4. So by replacement again, our B raised to 4 will be 3 maps to 1 maps to 3, 2 maps to 10, 3 maps to 6, 4 maps to 2, 5 maps to 4, 6 maps to 7, 7 maps to 9, 8 maps to 5, 9 maps to 1, and 10 maps to. So recall that A times C. So A times C is equal to 1 maps to 1, 2 maps to 10, 3 maps to 8, 4 maps to 9, 5 maps to 2, 6 maps to 4, 7 maps to 5, 8 maps to 6, 9 maps to 3, and 10 maps to 7. So we can now have A times C times B raised to 4. So our A times E times B raised to 4 will be 1 maps to 8, 2 maps to 7, 3 maps to 4, 4 maps to 10, 5 maps to 9, 6 maps to 5, 7 maps to 3, 8 maps to 2, 9 maps to 1, and 10 maps to 6. So by replacement, we will find the inverse of A times C times B raised to 4. So our inverse of A times C times B of raised to 4 will be 1 maps to 9, 2 maps to 8, 3 maps to 7, 4 maps to 3, 5 maps to 6, 6 maps to 10, 7 maps to 2, 8 maps to 1, 9 maps to 5, and 10 maps to 4. So our one-line notation will be 1, 9, 5, 6, 10, 4, 3, 7, 2, 8 in S sub 10.
For number 46 to 50, think of a strategy on how to simplify 1, 7, 5, 2, 3 raised to 83 in S7. Explain the strategy in no more than 5 sentences, then solve. To simplify po, in the set of 7, the LCM of the permutation is 5. So since 5 is not visible by 83, we will manipulate the exponent 83 by adding -2, since 85 is closer to 83. Now that we have 85 as our exponent, then we can now have our LCM, which is 5. We can now have 1, 7, 5, 2, 3 raised to 5. Recalling that the LCM of 85 is 5. So clearly po, we have this mapping for 85. 1 map to 1, 2 maps to 2, 3 map to 3, 4 map to 4, 5 map to 5, 6 map to 6, and 7 map to 7. By the law exponent po, since 83 is close to 85, imamanipulate po natin yung ating exponent. We will have 17523 raised to 85 and 17523 raised to negative 2. Recall that 17523 raised to 85 is equal to the identity. By replacement, 1 map to 1, 2 map to 2, 3 map to 3, 4 map to 4, 5 map to 5, 6 map to 6, and 7 map to 7 multiply by 17523 raised to negative 2 is equal to 17523 or raised to 83 or yung given natin. Now let 17523 be J. Yung given po natin. So by two-line notation, we will get J is equal to 1 map to 7, 2 map to 3, 3 map to 1, 4 map to 4, 5 map to 2, 6 map to 6, and 7 map to 5. Recall that 17523 raised to 5 is equal to the identity. So 1 map to 1, 2 map to 2, and so on. So by replacement po, we will have J raised to 5 is equal to 1 map to 1, 2 map to 2, 3 map to 3, 4 map to 4, 5 map to 5, 6 map to 6, and 7 map to 7. So recall again that 17523 raised to 85 is equal to the identity. So by substitution, J raised to 85 is equal to 1 map to map, 1 map to 1, 2 map to 2, 3 map to 3, 4 map to 4, 5 map to 5, 6 map to 6, and 7 map to 7. Solve for J. So recall that J raised to 83 is equal to J raised to 85 minus J raised to negative 2. Recall further that J is equal to 1 map to 7, 2 map to 3, 3 map to 1, 4 map to 4, 5 map to 2, 6 map to 6, and 7 map to 5. Solve for J raised to negative 1 or yung J inverse. Ang ating J inverse is equal to 1 map to 3, 2 map to 5, 3 map to 2, 4 map to 4, 5 map to 7, 6 map to 6, and 7 map to 1. So now solve for J in J raised to negative 2. So J raised to negative 2 is equal to J raised to negative 1 and multiply by J raised to negative 1. So we will have this, and when we analyze the mapping, we will get 1 map to 2, 2 map to 7, 3 map to 5, 4 map to 4, 5 map to 1, 6 map to 6, and 7 map to 3. So in two-line notation, J raised to negative 2 is equal to is 1 map to 2, 2 map to 7, 3 map to 5, 4 map to 4, 5 map to 1, 6 map to 6, and 7 map to 3. Next po. So recall that J raised to 83 is equal to J raised to 85 minus J raised to negative 2. So by substitution, we will get this, and when we analyze the mapping, we will have J raised to 83 is equal to 1 map to 2, 2 map to 7, 3 map to 5, and 4 map to 4, 5 map to 1, 6 map to 6, 7 map to 3, which is yung ating given. Next po. In one notation, when we analyze the mappings, we will have 1 map to 2, 2 map to 7, 7 map to 3, and 3 map to 5. Therefore, J raised to 83 is equal to 1, 2, 7, 3, 5 in S7.
Okay, next we have let H equals to the set of the element of 3 raised to n, 5 raised to m, where m and n is an element of Z. And the question is H a non-trivial subgroup of R? Under multiplication, justify. So by using the theorem of subgroups, we need to show that H is a subgroup of R. So to show that H is non-empty, we have H equals to 3 raised to n minus 1 times 5 raised to m minus 1 and 3 raised to n times 5m raised to m. And we have 3 raised to n plus 1 and 5 raised to m plus 1 where n and m is an element of Z. That's why H is non-empty. Show that if A and B is an element of H, then AB is an element of H. So let 3 raised to n, 5 raised to m equals to H, element of H, and 3 raised to x, 5 raised to y is an element of H, where m, n, x, and y is an element of Z. By multiplication, 3 raised to n times 5 raised to m times 3 raised to x times 5 raised to y is an element of H. By product of law of exponents, we have 3 raised to n plus x times 5 raised to m plus y is an element of H. And since m and x and y is an element of Z, then n plus x and m plus y is an element of Z. Clearly, this statement satisfies the definition of its set. Hence, closure properties satisfied. So next, we need to prove that if A is an element of H, then A inverse is an element of H. Let 3 raised to n times 5 raised to m is an element of H. So by multiplication inverse, we have 3 raised to n, 5 raised to m inverse equals to 1 over 3 raised to n times 5 raised to m. So we need to show that 1 over 3 raised to n times 5 raised to m is an element of H. And by definition of negative exponent, we have 3 raised to negative n times 5 raised to negative m, element of H. Since negative n and negative m is an element of Z, then the inverse is found in the set of H. Hence, the three properties were met. H under multiplication, a non-trivial subgroup of R under multiplication, where H is an element of 3 raised to n, 5 raised to m, where m and n is an element of Z.
For 56 and 260, let G for set of A be a cyclic group of order 28. Find the subgroups and generators of G. So yung G po natin is A raised to 1 to A raised to 28, where yung identity is A raised to 28. And ang ating order of G is equal to 28. Recall that the order of the subgroup must be a factors of order of G. So ang order of G natin is 28. Therefore, ang factor niya is 1, 2, 4, 7, 14, and 28 itself. So let H be the subgroup. If the order of H is equal to 1, we will get the identity, which is yung H is equal to E. If ang order of H natin is equal to 2, when we divide 2 to 28, we will get A raised to 14 and A raised to 28, which is yung factor ng 14. Order of H is equal to 4, we will get H is equal to A raised to 7, A raised to 14, A raised to 21, and A raised to 28. If the order of H is equal to 7, we will get H is equal to A raised to 4, A raised to 8, A raised to 12, A raised to 16, A raised to 20, A raised to 24, and A raised to 28. Next, if the order of H is equal to 14, for 28 divided by 14 is equal to 2, our H is equal to A raised to 2, or all the even number from 2 up to 28. If order of H natin is equal to 8 to 28, 28 divided by 28 is equal to 1, we will get A up to 28. So since G is equal to order of 28, we will get H is equal to G. Therefore, ang subgroup natin, which is yung mga unang unang element na naandito sa atin, we will get E, A raised to 14, A raised to 7, A raised to 4, A raised to 2, and then yung A. To solve for the generator of G, A raised to I must be solved where I and order of G must be relatively prime. Therefore, yung I natin is yung mga element ng ating G na hindi factor ng ating order of G. We will get 3, 5, 6, 8, 9, 10, 11, 12, 13, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, and 27. So para makuha po natin yung generators, we have to solve for the GCD. So 3 and 28 is equal to 1, 5 and 28 is equal to 1, 6 and 28 is equal to 2, 8 and 28 is equal to 4, 9 and 28 is equal to 1, 10 and 28 is equal to 2, 11 and 28 is equal to 1, 12 and 28 is equal to 4, 13 and 28 is equal to 1, 15 and 28 is equal to 1, GCD of 16 and 28 is equal to 4, 17 and 28 is equal to 1, 18 and 28 is equal to 2, 19 and 28 is equal to 1, 20 and 28 is equal to 4, 21 and 28 is equal to 7, 22 and 28 is equal to 2, 23 and 28 is equal to 1, 24 and 28 is equal to 4, 25 and 28 is equal to 2, and last 27 and 28 is equal to 1. So to look for the generator, we must find those elements wherein yung GCD nila is equal to 1. So we will get I can be 3, 5, 9, 11, 13, 15, 17, 19, 23, 25, and 27. So the generators are A raised to 3, A raised to 5, A raised to 9, A raised to 11, A raised to 13, A raised to 15, A raised to 17, A raised to 19, A raised to 23, A raised to 25, and A raised to 27. For 61 to 70, construct a Cayley's table of the symmetries in A square. Is it a permutation group and justify?
So we have a reflection of the y-axis, which is y equals to 1 maps to 4, 2 maps to 3, 3 maps to 2, and 4 maps to 1. Next, we have the reflection about the y-axis. So x equals to 1 maps to 2, 2 maps to 1, 3 maps to 4, and 4 maps to 3. Next is we have the reflection about the diagonal. So the diagonal is D1. So we have 1 maps to 1, 2 maps to 4, 3 maps to 3, and 4 maps to 2. Next is we have D2, which is the diagonal equals to 1 maps to 3, 2 maps to 2, 3 maps to 1, and 4 maps to 4. Next is we have rotation about 90 degrees, or R90, which is equal to 1 maps to 2, 2 maps to 3, 3 maps to 4, and 4 maps to 1. Next, we have rotation about 180 degrees, which is our R180, equals to 1 maps to 3, 2 maps to 4, 3 maps to 1, and 4 maps to 2. Next, we have rotation about 270 degrees, which is R270, which is 1 maps to 4, 2 maps to 1, 3 maps to 2, and 4 maps to 3. Lastly, we have our 360 or degrees, or our R360, which is equal to 1 maps to 1, 2 maps to 2, 3 maps to 3, and 4 maps to 4, which is also our identity. Since we have R360 as our identity, nilagay ko na lang po yung mga kaparehas nila, yx, D1, D2, R90, 180, 270, R360. So next, so first, we have to multiply y by y, and the answer is 1 maps to 1, 2 maps to 2, 3 maps to 3, and 4 maps to 4. So it is also equals to R360. Next, we have y multiplied by x. We have 1 maps to 3, 2 maps to 4, 3 maps to 1, 4 maps to 2, which is also R180. Next, we have y multiplied by d1, which is, the answer is 1 maps to 4, 2 maps to 1, 3 maps to 2, and 4 maps to 3, which is also our R270. Okay, so next is we have y multiplied by d2, d sub 2. Okay, so we have the product of 1, 2, 1 maps to 2, 2 maps to 3, 3 maps to 4, and 4 maps to 1, which is also our R90. Next, we have y multiplied by R90, which is 1 maps to 3, 2 maps to 2, 3 maps to 1, and 4 maps to 4, which is also our D2. Next, we have y times R180, which is the product. The product is 1 maps to 2, 2 maps to 1, 3 maps to 4, and 4 maps to 3. It is also our x. So sa first row natin, ang kulang na lang ay D1. So nilagay ko na lang po yung D1. So next po tayo, proceed tayo sa next row, which is x multiplied by y. We have 1 maps to 3, 2 maps to 4, 3 maps to 1, and 4 maps to 2, which is also our R180. Next is x multiplied by x, which is equal to 1 maps to 1, 2 maps to 2, 3 maps to 3, 4 maps to 4, which is also our R360. By multiplying x to d1, we have 1 maps to 2, 2 maps to 3, 3 maps to 4, and 4 maps to 1, which is also our R90. Next is we have x multiplied by d2, which is 1 maps to 4, 2 maps to 1, 3 maps to 2, and 4 maps to 3, which is also our R270. Next, we have x multiplied by R90. We have 1 maps to 1, 2 maps to 4, 3 maps to 3, 4 maps to 2, which is our D1. So x multiplied by R180, we have 1 maps to 4, 2 maps to 3, 3 maps to 2, and 4 maps to 1, which is also our y. So for the row, wala pa tayong D2. So nilagay ko na lang po yung D2. So next row, we have D1 multiplied by y, which is also our 1 maps to 2, 2 maps to 3, 3 maps to 4, and 4 maps to 1. So which is also our R90. So proceed tayo. Meron tayong D1 multiplied by x, which is 1 maps to 4, 2 maps to 1, 3 maps to 2, and 4 maps to 3. So it is also our R270. So next we have D1 multiplied by D1. So the answer is 1 maps to 2, 2 maps to 2, 3 maps to 3, 4 maps to 4, which is also our R360. Next we have D1 times D2. So 1 maps to 3, 2 maps to 4, 3 maps to 1, and 4 maps to 2, which is also our R180. Proceeding, we have D sub 1 multiplied by R90, which is R maps to 2, 2 maps to 3, 3 maps to 2, 4 maps to 1, which is also our Y. Next, we have D sub 1 multiplied by R180, which is 1 maps to 3, 2 maps to 2, 3 maps to 1, and 4 maps to 4, which is also our D2. So kulang tayo ng X, so ilalagay ko na lang yung X. Next, we have d sub 2 multiplied by 1. So we have 1 maps to 4, 2 maps to 1, 3 maps to 2, 4 maps to 3. So, which is also our R270. Next, we have R sub 90, which is multiplied by Y. We have 1 maps to 1, 2 maps to 4, 3 maps to 3, 4 maps to 2, which is also equals to D1. Next, meron po tayo, i-multiply natin R180 sa Y. The answer is 1 maps to 2, 2 maps to 1, 3 maps to 4, and 4 maps to 3, which is also our X. So, sa column, meron na lang tayong, wala na lang tayong D2. So, ilalagay ko na yung D2. And next, we have D2. D sub 2 multiplied by X, we have 1 maps to 2, 2 maps to 3, 3 maps to 4, and 4 maps to 1. So, it is also our R90. Next, we have D sub 2 times D sub 1 equals to 1 sub 3, to 1 maps to 3, 2 maps to 4, 3 maps to 1, and 4 maps to 2, which is also our R180. Next, we have to solve the R sub 90 multiplied by X, which is 1 maps to 3, 2 maps to 2, 3 maps to 1, 4 maps to 4, which is also our D sub 2. Next, we have to multiply R sub 180 multiplied by X equals to 1 maps to 4, 2 maps to 3, 3 maps to 2, and 4 maps to 1, which is also our Y. So, sa column na X, meron na lang tayong D1. So, ilalagay ko na lang po yung D1. Next, we have R sub 90 multiplied by D1. We have 1 maps to 2, 2 maps to 1, 3 maps to 4, and 4 maps to 3. So, that is also equal to X. Next, we have R180 multiplied by D sub 1 equals to 1 maps to 3, 2 maps to 1, 2 maps to 2 rather, 3 maps to 1, 4 maps to 4. So, it is also D sub 2, and ilalagay ko po is Y. Kulang na ng Y. Next, we have D sub 2 multiplied by D sub 2. So, we have 1 maps to 1, 2 maps to 2, 3 maps to 3, and 4 maps to 4, which is also our R360. Next, we have R sub 90 multiplied by D sub 2, okay, equals to 1 maps to 4, 2 maps to 3, 3 maps to 2, and 4 maps to 1, which is also our Y. So, proceed. We have R sub 180 multiplied by D sub 2. We have 1 maps to 1, 2 maps to 4, 3 maps to 3, and 4 maps to 2, which is also our D1, D sub 1. So, I'm gonna put X sa baba kasi yun na lang yung kulang. So, next we have D sub 2 multiplied by R90. So, the answer is 1 maps to 2, 2 maps to 1, 3 maps to 4, and 4 maps to 3. We have our X. So, R90 multiplied by R90 is equal to 1 maps to 3, 2 maps to 4, 3 maps to 1, and 4 maps to 2, which is also our R180, R sub 180. So, proceed. We have R1 sub 80 multiplied by R sub 90, which is also our 1 maps to 4, 2 maps to 1, 3 maps to 2, and 4 maps to 3. So, we have R270, and lalagay ko na lang po yung lalagay na lang yung R sub 360. Next, we have D sub which is also our D sub 1. So, next, we have R sub 90 multiplied by R180. We have 1 maps to 4, 2 maps to 1, 3 maps to 2, and 4 maps to 3, which is also our R270. Next, we have R sub 180 multiplied by R1 sub 81. R sub 180, which is also the product, is our identity element. So, I'm gonna put R sub 360, and dahil dito, makukompleto na natin table. So, meron na tayong R360, mag-R90, Y, tapos ipipill up ko na yung mga kulang sa rows and columns. So, to test, if it is a permutation group, we have to test for closure, associative, identity element, and the inverse. So, first we have, since all the elements of the K-list table are from the permutation, thus the permutation is closed. Next is the associativity. And since all the elements have no counterexample, the permutation is associative. So, identity element natin, and we know that R260 is our identity element, and hence the identity element exists. So, furthermore, testing for inverse for each element of the permutation, we have Y inverse is also Y, X inverse is also X. D sub 1 inverse is also D sub 1, D sub 2 inverse is also D sub 2, sub 90 is also inverse is also R sub 270, R sub 180 inverse is also R180, R sub 270 inverse is equal to R sub 90. And lastly, we have R sub 360 inverse is equal to R360. And since the permutation satisfies closure, associativity, and has an identity element, and there exists an inverse for every element, thus it is a permutation group. So that's all. Thank you. And again, we are the group 4.